Students, this question was asked in NEET 2023 from chapter 12 of class 12, that is student from the chapter atoms. The radius of innermost orbit of hydrogen atom is 5.3 into 10 to the power minus 9 meter. What is the radius of the third orbit of hydrogen atom? Students, we have studied the Bohr's model of atom, students. Bohr's model of hydrogen atom. Okay, student. According to this model, there is a nucleus in which there are protons, positively charged protons, and the negatively charged electrons are revolving around the nucleus in certain specified orbits. What is the condition? We will study later, students. Okay, and this let us the radius of the orbit be r. Okay, students. Then why these electrons are not falling into the nucleus? Due to the Coulombic attraction between the positively charged proton and the negatively charged electron, because of the centrifugal force of rotation. Okay, student, which is in magnitude equal to the centripetal force. And what is the formula for centripetal force, student? We have studied in circular motion, that is F is equal to mv square by r. This mv square by r, or centripetal force, balances the Coulombic force of attraction, that is we have studied 1 by 4 pi epsilon 0 q1 q2 by r square. And what is q1 and q2 here? q1 is also E, the charge on the proton is same as the equal to the charge on the electron, student. We have studied 1.60 to 06 into 10 to the power minus 19 coulomb, but the charge on proton is positive and on the electron is negative. So student, we write here E dot E by R square. So student, we may write mv square is equal to this R cuts this R square, and this becomes square by 4 pi epsilon 0 r, student. Okay, then this b square becomes square by 4 pi epsilon 0 m r. Okay, student. So this is the formula for the velocity we can get. If you take the root of this quantity, we get the formula for velocity. Then what will be the angular momentum of the electron, student? That is, we know the formula is mvr. This is the linear momentum mv, and this is the radius of the circle in which the electron is executing circular motion. So L is mvr, student. So we multiply mr with v. Okay, students. Mr with v, and v is given above square by 4 pi epsilon 0 mr. Okay, student. We take mr into the inside the square bracket. So this becomes square m square r square by 4 pi epsilon 0 mr. So this m cuts this square, this r cuts this square, and this becomes root over square mr by 4 pi epsilon 0. And now the question arises, in which orbits the electrons are allowed to revolve? And from quantum hypothesis of Max Planck, we know, student, that angular momentum is conserved and that is quantized, that is n equal to n h cross. So in the nth orbit of hydrogen atom, the angular momentum will be integral multiple of h cross, or that is nh by 2 pi. Okay, student. So student, we write here, we equate that, and here we have got the formula for angular momentum. So root over square mr by 4 pi epsilon 0 is equal to how much? n h by 2 pi. Okay, student. So if we take the square of both the sides, this becomes, the square root is gone, and this becomes n square h square, and this 2 becomes 4, and this becomes pi square. Okay, student. And from this we can get the formula for radius of hydrogen atom. Okay, student. What will be then? This 4 will cancel, and this pi will cut this square, and pi will remain here. Okay, student. Then this will be equal to R will be equal to how much? N square into H square, and this epsilon 0 will be multiplied there, epsilon 0. This MR will go this side. Okay, student. M square will go below. This will be pi M E square. You see, student, this n is variable. There are various orbits. First orbit, second orbit, third orbit. N is equal to 1 means first orbit, n is equal to 2 means second orbit, n is equal to 3 means third orbit. And you see, h is Planck's constant. Epsilon 0 is the permittivity of vacuum, which is also a constant. Pi is equal to 3.14, which is a constant. Mass of electron, we know, student, 9.183. Mass of electron is 9.183 into 10 to the power minus 31 kg. That is also constant. And E, the charge on the electron is 1.60206 into 10 to the power minus 19 coulomb, which is again a constant. So all the quantities inside the bracket are constant, student. So this value is a constant, and that is equal to 0.53 angstrom, which is given above. That the radius of innermost orbit of hydrogen atom is, this means, student, 0.53 angstrom, because angstrom is 1 angstrom is 10 to the power minus 10 meter. We can write this as 0.53 into 10 to the power minus 10 meter, but 0.53 angstrom. So, student, R becomes 0.53 angstrom into n square. Okay, then R1, the first orbit, will have radius 0.53 angstrom. The second orbit will have will have radius 0.53 into 4, and the third orbit. The question is, what is the radius of the third orbit of the hydrogen atom, student? So here n is 3. So this will be R will be equal to n square into 0.53 angstrom. So student, here n is 3. This is 9 into 0.53 angstrom. So student, 9 into 3, 7, 2 is taken, 9, 5, 45 to 47. So this is 4.77 angstrom, student, which is in option B. So option B is correct, students, for this question.